And all of the times, I don't always record the office hours, but I record parts of them and they end up in the YouTube playlist that's in the course information section. All right, so whereas you're gonna start with a data set and stat key, I'm gonna just stick my own in here. And getting it in here can be a little tricky because if you don't paste it just right, then it does not work. And I gotta put commas in between each element in order for this to work properly. Otherwise the computer will freak and give me an error. Luckily, this is a small data set. There are automated ways to do this for bigger data sets, but that takes a little time. All right, so I think my data's in there right. So what I should see is pretty much the same graph that Google Sheets was showing me. They just show a slightly different scale here, and the points are different sizes. And then I can ask it to show the regression equation. Off to the side here, they calculate a bunch of statistics. They give me a mean and a standard deviation for the times, a mean and a standard deviation for the distances. We don't need those, but I will talk about them a little bit today to explain one of the ideas in section 3. They tell me the sample size is 6, the correlation coefficient is 0.8, which is relatively high. The highest you can get is 1. The only way you get a 1 is if the points perfectly lined up, that there's no deviation from straightness. And so the correlation coefficient is kind of a measure of straightness. If it's positive, it means it slopes uphill. If the correlation coefficient is negative, it means slopes downhill. So positive and negative don't mean good and bad, they just mean uphill or downhill. If the correlation coefficient is close to 0, that means it's just a cloud of points and we don't see a trend. If it's closer to 1 or -1, that means the points roughly line up. Then they give me the slope of the line they drew, and that is a very special line that I'll explain in a moment. And they give me the y-intercept. And what I ask of you in this exercise is to get a data set based on what StatKey tells you the slope and the intercept is. Write down your equation and then tell me what the slope means, tell me what the intercept means, and tell me what your correlation coefficient means, and then talk about whether this model could be useful or not. Now, if it's useful, that means not only do we find correlation, and correlation is just a mathematical measurement of do the points roughly line up or not? Are they uphill or are they downhill? And I can stick all kinds of data together that will give me a correlation, but it's crap, it's meaningless. The next question, is there causation? Is there some reason that an increase in time will lead to an increase in distance? Here I believe there is, right? I'm pushing on the pedals, trying to cover distance over time, right? So I am the cause of the relationship between time and distance. So for those other data sets, you gotta kind of think about, is there a reason these variables might be connected? So that's part of the challenge here. So StatKey does all of the work for you, then it's just a matter of answering the questions that I asked about in the activity. And I have all these different numbered out things I want you to address, and many people address them as number 1 and number 2 and number 3. I don't ask you to do that. What I ask here is for you to write up this whole thing explaining it to me and my mother. And keep in mind, my mother does not have a degree in math. She's pretty smart, but she doesn't know as much math as me. So if I start throwing in words like interpolate and extrapolate and causation and correlation and regression, she's gonna be like, I'm just gonna lose her. She's gonna say, hey, yeah, so what are the kids doing? And so I wanna keep her engaged. I wanna describe this stuff to her in a way she will understand too. So you have to think about that as you write up your answers. So I'm gonna do that with my mom in mind for this particular example. So I have to be able to explain what the independent and dependent variables are. I got to state the model that StatKey is trying to give me. I need to show a picture of the regression equation, and then what is the value of the correlation coefficient and so on. So I'm going to try to do that now. With StatKey, if you choose, well, you should use StatKey. Again, you don't have to use a spreadsheet. To get a graph like this into your post, then you will have to do a screenshot. You cannot right-click and copy the image. It doesn't work. They haven't fixed that yet. So they have great services, but that's not one they prioritize. So if I want to get a picture of that, I usually zoom in on it a little bit. So I'm going to Control+ on this. And then I'm going to use the snipping tool to grab a screenshot because I want this to be in my post. So snip if you're a Windows user. If you don't know how to do a screenshot, let me know. I believe I posted a video. I did. There's a video in the announcements on that, and it's also in my playlist. So computer says use snip and sketch, but it doesn't have it installed. So we'll just do a new snip here. And it is wanting to snip the other screen. Okay, interesting. If I move you over there and say new, still screws up. Okay, give me a second. My two-screen system is, whoa, it did it. Okay, but it's not the right size. So let's try that again. No, I don't want to save it. All these technical difficulties. That's one downside of what's going on here is I'm on the computer way too much, and I assume you guys are too. So I hope you find a way to get outside and go for walks, say hi to your neighbors. All right, let's see if it works this time. Now it wants to snip the other screen. What the hell? Well, this is annoying. Okay, so it's not letting me take a screenshot. We'll have to do it. Oh, wait, I know. I want a rectangular snip. All right, let's see if this fixes it. New. There we go. Okay, so it was user error. All right, got my snip. Save it. Put it somewhere you'll find it. So what is this? This is bike ride line. Close. Let's bring this back so you can see. All right, so I got this thing from Stacky. In order for you to put it in your post, it works kind of the same way as when I make a post. You start by doing your reply. And then to put an image in, out of the way again, you go to Canvas and then you select your files, and then that lets this upload button work. So then you can go grab your image. And so what did I call it? Bike ride line, and then open. And it wants you to put in some alt text for screen readers. It grabs the name of the file. So usually I just give it a slightly better alt text. So this is for somebody that can't see, like when my stepfather goes to look at my stuff, he doesn't see, so he'll need his screen reader will look for that description. So bike ride regression line, that's gonna be enough for now. The image size came in at about the size of my screen, which is huge. So I don't want to display it that big. And if you resize one dimension and then click, it will automatically calculate what the other one should be so it doesn't squish your picture, and then that'll throw it in there. And then you can write above or below it. So right now my cursor is flashing to the right, so if I hit enter, I can type stuff underneath. And if I wanted to get in front of it, I can just kind of hit the up arrow to the left and then enter and up, and I can now type above it. So you can put an image in there, and I'd like you to do that. So if you don't know how to use the snipping tool, watch that other video or rewatch this and figure that out. So I should put a title at the top, and kind of like when you titled your graphs back 2 weeks ago, for the application, you want to write a reasonably good title. So this would be Gary's bike rides, hours versus miles, or miles versus hours, either way is fine. All right, so then I should right away define my variables. Okay, so this example, independent variable, independent, and I'm going to use some big words, but not too many, is the time I spent writing. Let's make time different. Let's just say hours there. Dependent variable is the distance, about miles traveled in that time. And then I'm just going to make a note, like why I'm calling one independent and dependent. Seems to me that the distance traveled depends on the time spent biking. All right, more time, more distance. All right, so there's my intro to the variables. What else do I have to talk about here? State the model. Okay, so Stacky gave me the model. It says your slope is about 7 and your y-intercept is about 1. So let me make a quick note of that. 7.089 and 1.347. Now Stacky only gives us a few decimal places, and usually when we make statistical calculations, we go one more place than the data. So what did my data look like? My data had 2 decimal places, so then I want to go with all of the decimal Stacky gave me. So I'm going to use those numbers in their entirety. So back to my post here. So model here is y equals 7.089. Is that what it was? Yep. X plus 1.347. And if you want, there is an equation editor here that you could use to make it slightly prettier, but it's easy enough to type. I don't think I need that. And since I'm using y and x here, I guess I better put that up in my description. So for this example, the independent variable, so I should put a note, comma, x, and the dependent variable, y. Okay, so I now say what x is, I say what y is, I use them in the equation here. All right, so I got that covered. And I'm not worried about numbering these. I didn't ask you to number them like I do with the critical thinking. That's just for me to see that you have some word processing skills. And if you don't, for me to help you learn them. And if you want to number them, that's fine too. I was just looking for kind of like a paragraph type thing or several paragraphs. Graph the data, got it, I put that at the top. What is the value of the correlation coefficient and what does it tell us? Okay, so Stacky says the correlation coefficient is 0.837. And I do want to compare that to what a spreadsheet gives me because I use spreadsheets for my homework usually. All right, let's see. There seems to be a strong connection, I'm thinking about my mom here, between these variables. That key gives a, I'm going to use a big word again, correlation of 0. What was it, 8 something, 837. 837, which is close to 1. What else do I want to say about that? Since it is, and we'll do spell check later, it is positive. That means as time increases, so does the distance. And that brings me into the next question, which is to interpret the slope. So what does that number 7.089 mean? And I'm going to whip out my notebook to analyze that for a second. So on a problem like this, I go back and forth between playing with something like a spreadsheet or a graphing calculator or Stacky and then writing down notes to kind of figure stuff out. So I'm looking at my bike rides here. That's my situation. And I have X is hours ridden and Y is miles traveled. And my slope we usually give the letter M. We call that like the rise over the run. And the rise, come on, pen, is the change in the y values, right? That whole y2 minus y1 thing. And the run is change in your x values. And in order to tell what the slope means, I need to be more specific, right? My mom's not going to appreciate me saying change in y. What is y? Well, y is the miles traveled, so it's a change in miles. Change in miles. And what is x? Well, x is really hours, so this is really a change in the bottom in hours. And my slope is about 7, so it's 7.089, but I'm just going to call it 7, close enough. I need to write 7 as a fraction, and so I'm going to choose to write it 7 over 1. And that would be 7 miles to 1 hour. And note, that's a positive 7 and that's a positive 1. So now I want to put this in terms of a sentence. And remember, I believe that x is my independent variable and y is dependent. And so when I state the sentence, I'm going to say how the independent variable changes the dependent variable. And I want to use these numbers to make that happen. All right, so here goes my best sentence. And there were some examples of this in the practice problems. All right. Slope on the computer is about 7 miles per hour, right? This means, there's a couple ways I could interpret it, that every additional hour, and why do I say additional? Because again, slope is a change. That means something went up or something went down. In this case, it's positive, so I'm using the word additional. I could have used the word more or an increase, but something to imply the change, because slope is change over change. So that means for every additional hour bikes travels another, right, an increase type word, 7 miles. So in general, your sentence is going to look something like that. In this case, the 7 turns out to be my average speed, which my first sentence is kind of getting at. But this is kind of a more generic sentence, but it's an interpretation, right? What does it mean? And telling me that slope means rise over 1 and that I subtract these two numbers from those two numbers and divide, that's not an interpretation. That's a definition. That's a calculation. Interpretation means, how would you explain this to your mother? How would you explain this to your boss who doesn't know as much math as you do but asked you to do something? So that's what it means to interpret, to explain to somebody who doesn't get it. Okay, I also need to interpret the y-intercept. So that key claims that the y-intercept, and y-intercept is also known as an initial value. Is about 1.347. All right, now back to my notebook to kind of puzzle out what that number means. So let's switch colors. Y-intercept. A y-intercept, often we give it the letter B, is actually a point. It's the point 0, B. So x is 0 and y is B. So for me, that means 0 hours means 1.347 miles. So in a sentence, if Gary bikes no time, he's gone 1.347 miles. What? That's crazy talk. Nonsense. However, I can't just blow it off, because if I do, I won't get the right line. So I'm going to go look at that in my spreadsheet for a sec. Non-bike rides. Okay, so if I round 1.347 to 2 decimal places, I get 1.35, which is what Google said it was. And if I rounded that 7.089 to 2 decimal places, Google says it's 7.9. So Google agrees with stat3, which they should here because they're supposed to be doing the same math. I'm just going to throw in a slightly different version of this formula. I'm going to call this model 2. And here I'm just going to say, you know, this is stupid. Gary can't go 1.35 miles if he hasn't biked any time. That's crazy. So if Gary hasn't biked, he's gone no distance, right? So what would that look like? So I'm just going to throw some points in there to show what that looks like. That means the calculation would be to take the slope, 7.089, and just multiply by the time, and just neglect to add on that 1.35. So I'm just not going to do it because I think it's crap. And then I'm going to fill that down. So what the computer is going to do is it's going to recalculate the distance for each of those times, ignoring that y-intercept the computer gave. And then I'm just going to add that to the graph. Actually, I'm just going to make a new graph. Just grab all of that and chart it out. Okay, and then let's see, can I just add a line for model 2? You can kind of see what's going on here. No, I'm gonna actually try to add the regression line. Which data set am I on? I just want to do it to distance. Okay, trend line. All right, so here you can see the, oh, I might as well do the other one too. What the hell, why not? Try that again. Okay, so the blue line is the one that goes with my actual data set right here. The red line is my alternate model. And notice that the blue line and the red line have the same slope. The red line is just lower. So the catch here is the blue line fits the data better, and it fits the way the computer calculates fitting the data. If you look at the distance between each point in the line, reality is a point, the line is a guess. The line, the blue line, is on average closer to all of the points than any other line in existence, is the way this calculation works. Okay? The technical details of how that happens, if you wanted to know about that, you'd have to take a couple more stats courses to get into those technical details. It involves some calculus. So we're not going to get to that here. We're just going to use the results. So although the red line, I think, is nice because it reflects reality in that if I don't spend any time biking, I'm not going anywhere. But the blue line throws in a y-intercept to say, if we shift it up a little, it fits better. And that's life. Okay? And sometimes there's a dramatic difference between a practical y-intercept and a one that correlates better. Other times they're pretty darn close. And here it's like, it's not much different. For my purposes, my model where I drop the y-intercept and call it 0 is probably good enough. But that's a whole nother issue. But I just wanted to point that out. So what's useful here? Well, when Google and stat3 create their models, the correlation coefficient is always useful. It tells us whether, mathematically speaking, the points kind of line up. Closer to 1 or -1 means yep. Closer to 0 means kind of sketchy. The slope is always going to be meaningful if you have a practical reason that you should be relating these two variables. And then the y-intercept, sometimes it's important, sometimes it's just kind of like a fudge factor we throw in to make things behave better. So the y-intercept is sometimes meaningful, but sometimes not. So if you have a high correlation, meaning the correlation is close to 1 or -1, then you probably have an important slope. And then the y-intercept, who knows? It depends on the situation. And you'll have to think about that. So coming back, I'm ready to type something up about that. Where'd you go? Is 1.34. So this means that if Gary spends no time biking, traveled 1.347 miles, because the y-intercept's a y value is my y-else. And then, no, that's crazy. It's just there. The points better. Because that's the way the calculation works. Okay, so you have to think about whether your y-intercept is meaningful or not, and then what I'm more concerned about is that you have a good interpretation of your slope. What does it tell us about how these two variables change together? All right, what else do we have? What does the slope mean? I got that, I got that, I got that. Interpolation and extrapolation. All right, let's do that. So interpolation means to look within the data. So in that case, let's see, I have my shortest ride was about 8/10 of an hour, and my longest ride in this scenario was a little over 2 hours. So that means to interpolate using this equation here is to plug in a time that's within the range of the data, or to plug in a distance within the range of the data. And my distances range from about 5 miles up to about 15 miles. Okay, so an interpolation is either picking a time in this range or a distance in this range. To extrapolate means to look outside of the data. So that would mean to pick a ride time of less than 0.8 hours or more than 2 hours. To pick a distance that's less than 5 miles or more than 15 miles would be to extrapolate. So I'm just going to think about that for a moment. Back here. All right. So what was my correlation again? That was 0.8. That's relatively high. Okay. So since there seems to be a strong relationship between these variables, let's be more specific, between time by x and the distance traveled, we should be able to use the equation to make predictions. Okay, for example, let's pick a number that's not in there. So a number that's not in there would be like, he did kind of 1.5 there, maybe 1 hour and 45 minutes isn't in there. So Gary biked one. And I'm not going to type all this out. That's taking too much time. I'm not the fastest typer. So the predictions I would make, I'm going to go back to my spreadsheet to do that. Actually, I can just use a calculator. I would say calculate the 7.089 times 1.75, 1 3/4 hours, and then add on that fudge factor 1.347. So this says, the model says, if Gary were to bike for 1 hour and 3/4, then he'll cover about almost 14 miles. And then talk about whether that seems reasonable. And then I would pick something, so that's inside, right? That's within, and I would say, hey, that's within his usual time and distance, so that seems okay. Then we could pick something outside. Now, on the outside, I'm going to pick something bigger, like let's suppose I go a little nuts and I say, let's try 5 hours and see what happens. So 7.089 times 5 hours plus 1.347. So if Gary were to go biking for 5 hours, he would cover like 40 miles. Now, I have done 5-hour bike rides before, but biking 5 hours continuously, there's not many people that can do that. And maybe when I was younger, but not at 50, I don't think I would pull that off. I would definitely take breaks there. But if I took breaks, could I cover 37 miles in 5 hours? Yeah, I could, as long as there wasn't too much uphill. So maybe like in Echo, Oregon, there's some trails that aren't as hilly. If I biked all of them twice, that would cover about 40 miles. And could I do that in 5 hours if I didn't count my breaks? Probably. So, and then you could say, hey, let's let them bike 50 hours and see how long it takes, 50 miles and see how long it takes. 50-mile mountain bike ride, not too many people do that, and I doubt Gary could do that. So think about whether looking outside of the data set, outside of the given numbers, is a reasonable thing to do. And it can be reasonable if you go a little outside, like this isn't too bad, but it's on the edge of reality. And one reason we can extrapolate is because we have a connection between the two variables. If that's causation, we cannot measure causation exactly. We can only measure correlation. Correlation says, do these two numbers go together mathematically? Can we measure it? The answer is yes. But just because we can do that doesn't mean we should, doesn't mean that there's a reality behind it. But this one there is. So I'm just gonna throw, let's see, is there anything else I need to address here? Because I want to show some examples of when you shouldn't do this. Might there be causation? Okay, and have I addressed that? I think I did up here already. There seems to be a strong connection between these variables. Since it's positive, no, I didn't address it there. How about up here? It seems to me that the distance traveled depends on the time biking. Yeah, so that's me talking about, is there causation, right? So I could be more clear. Pushing on the pedals. This causes to travel a certain number of miles. Okay, so again, just because there's a mathematical relation, that's correlation, doesn't mean there's a physical cause behind it. So I think I'm almost done, aside from typing up my examples here, and then make a prediction. So when I do my interpolation and extrapolation, I'm also making my prediction. And again, this note here is just kind of to reemphasize the why. Is it reasonable? Okay, so give an example of calculation using the formula within the data, give an example outside, and just make sure you've stated that these are reasonable or not, right? You may argue that that 5 hours, 37 miles is not reasonable. Oops, and I did post a video about me doing an example here, and I think there's like 4 different examples of me doing linear regression in my playlist, and now there's going to be this one here. Let's look at something outside of reasonable. Where did I put that? Math classes, where'd you go, math classes? These are not in order today. Let's put them in alphabetical order so I can find it. Math classes. mth243, there it is. And where did I put this? Under linear, perhaps? Correlation, probably. Okay, here's one here. I went over this in a previous day this week. I got data from the USDA about the per capita consumption of chicken. So in, for example, 2005, on average, people in the US ate 60 pounds of chicken per year. And I also have data from somewhere about the average daily precipitation in Montana. And if you look at these by year, if you pair them by year and look at the graph, as people consume more chicken, the amount of precipitation in Montana goes up. Okay? Does that mean all of us eating more chicken makes more rain in Montana? That's a bit sketchy. So although I can measure correlation between these two variables, it's nonsense to say there's causation. So just because we have two variables that the points line up doesn't mean there's a reason. Similar example, per capita sour cream consumption in the US versus motorcycle riders killed in non-collision transport accidents, right? As we consume more sour cream, there's more non-collision deaths of motorcycle riders. Is somehow sour cream causing motorcycle riders to die? Don't think so. Okay. So correlation is a mathematical calculation based on how one set of numbers relates to another set of numbers when we pair them up. Causation means there's a reason that this changing from here to here causes this to change from here to here. So as sour cream consumption goes down, is there a reason that should make collision deaths in motorcycles go down? I doubt it. Okay. So causation, we can't measure mathematically. That's something we have to look for scientifically to find connections between two different events. Causation is just a number we calculate. And sometimes that number is meaningless, like in this case. Okay, so those are all the big ideas in this section, all put together in this application. And so what I'm hoping from you, and normally I wouldn't type this all up here, but you could. I would be scribbling things on a piece of paper or maybe in a Word doc or a Google Doc, and then I would copy and paste it in here. And then once you think you like your answer, then post it. And then you'll be able to see what other people posted. And there's a bunch of good posts there already. And so you can compare your stuff to others and say, hey, I think I did a better job, or ooh, I could have done this different. And then next week I'll grade these and you can decide if you want to update anything. All right, that was a big question and answer. Have fun with that, I hope. Are there other questions? If not, feel free to check out. I'm glad you could join me for a little while.